Okay, so we're gonna start first with converging lens ray diagrams, and these are just the rules, right? These are not complete ray diagrams, so there's 3 rules for ray diagrams with a converging lens. Just before we start the rules, you will note that very similar to a mirror, this has a focal point here, and we have something called 2f. It's not the center of curvature anymore, because this is not technically a circle, right? So we're just going to call it 2 times f. It is a substitute for center of curvature, because we'll remember that from O to F was the same distance as F to C in our mirrors. Now we're just going to write 2Fs to make it the same distance. All right? And you'll notice that each lens has technically 2 focal points. So this is called the primary focal point over here. Primary. And this over here is the secondary focal point. Right, it's just this little f prime over there. This if you put a dash on, like right next to like an apostrophe, how you say that is f prime. So the little dash means prime, or you say it as prime. Right, so that's f prime, and this is 2f prime. Okay, that's just how things are called. I don't know why. You'll be doing a lot of primes in calculus grade 12. So. Yes, that's why primes are important. Everybody uses primes. And there's just a little dash on top to indicate like secondary or something, or next. Okay, we're going to go through this, I think, fairly quickly because the rules are very similar to what we have already done in the past. So, rule number 1, any ray parallel to the principal axis, I hopefully don't have to remind you what the principal axis is. It's the same thing as it was before, right? I should say actually, okay, we'll finish this. Principal axis refracts so that it passes through the focus or focal point. We'll just say focus. Instead of the vertex here, we have what is called an optical center. And we'll get to that in our 3rd rule. So we don't have this O there is an optical center right here. But okay, so we have an image here. So let's draw some rays that are parallel to the principal axis. That's just one of them like this. Well, so you're gonna have to, again, technically the light did bend here, and will bend again once it reaches the outside, but we're just going to go to the center line, and then we're going to refract it so that it goes through the focus, like that. What happened? Is this on the hub? Did I post that on the hub? Okay, perfect. Good. Huh? A ray parallel to the principal axis refracts so that it passes through the focus. Right here. Yeah, again, you're just going, it's parallel to the center line right here. As soon as you reach that, you draw the bending. Yeah, if that was your question. The center line there, this in the middle of the lens. Is everybody good for rule number 2? Ray passing through the secondary focus. Can everybody see? Yeah. Refracts or emerges parallel to principal axis. And you can see that this is very similar to what we would have drawn for mirrors, right? Parallel to principal axis through the focal point. Through the focal point, parallel to principal axis, or aimed at. There's no aiming at stuff here. This is just we take this top point, We're going to aim it through the secondary focus like so until that middle line. Again, I'm stopping at this middle line. After that, I'm drawing the bending. The bent ray will go parallel to the principal axis, like so. Everybody okay with this rule? Very similar to our mirror rules, right? No complications, hopefully. Rule number 3. Ray of light, or ray, whatever, passing through optical center, which is the O point. Does not bend at all. So if I take this ray of light, I'm going through the optical center, so I draw this incident ray. I don't have any bending. I'm just going to come out the other, just like so. Very easy. Oh, you can't see that. Oh, there we go. And this is similar to our, it's kind of a mix between our center of curvature and the vertex rules, but it's just a straight, you just draw a straight line. Pretty chill. Okay, and we'll remember these are for convex mirrors, right? Converging mirrors. These are ray diagrams for converging lens, which are I keep saying mirrors, I'm sorry. Convex lenses. There's a converging lens. You good? Yes, Daniel?
Could there be like an object on the other side of the lens, like either F and 2F?
Yeah. I mean, then you'll just switch F into F will become F prime and F prime will become F.
So it has to be on the side of 2F prime.
Yes, essentially. The first focus is always on the other side of the lens for a convex lens. Right, so I don't know if I posted the other PowerPoint as well. These are a summary of the rules. Right? So these are the 3 rules. You've already written them down, don't write them in. We're good? We're good for convex lenses, converging lenses. Okay? Rules are good. We're going to our next page here, which is a diverging lens ray diagram. We only have 2 rules that we're doing here. We generally ignore the 3rd rule. Hypothetically, there could be a 3rd rule, but we're just going to do 2. The first rule is the same as our first rule from before. First rule is ray parallel to principal axis emerges or refracts as if from the focal point. And notice here, Daniel especially, that the F and F prime are switched, right? For a concave lens, the F is on the same side as the object. The F prime is on the other side, because this is the primary focal point.
So that's prime and that's secondary?
Yeah. So for a concave lens, it's flipped. So F prime is the secondary focal point, and F is the primary focal point. And it's the primary focal point because, in essence, when we draw array diagrams, right, when we draw an array that's parallel to the principal axis, we don't draw it through the secondary focal point. It's diverging. So it's going to come from or emerge from the primary focal point in a diverging fashion. Like so. Yes, it is. If you extend it backwards, it appears to come from the focal point. Right? You don't have to extend it backwards, but that's where I'm getting that ray from the focal point. And, well, maybe I should have ordered those differently. Is everybody good with the first rule?
Yes.
Second rule is the same as the third rule. Ray passing through optical center does not bend. Right, go straight through. And we draw a very similar diagram to what we drew. Before. Oh, can't see. There we go. The third rule is kind of, there's no third rule, there's two rules. Third rule is complicated and difficult to come by, so we're not going to do that. And the third rule is a way of like aimed at, secondary focus. If it's aimed over here, it bends so that it goes through parallel to the principal axis. It's the same idea, but we don't use that rule because it's unnecessarily complicated, and we're not always given f prime, so in calculation wise it's not that useful. True rules will always get an image. We need only two. And I like the second rule. It's nice. It's just a straight line. It's beautiful. Yes, for a concave, the f prime is on the other side. So the principal focus is defined as where a light comes from or goes to when it's parallel to the principal axis, right? We noted that for convex, when it was parallel to the principal axis, it went through this focal point. So this was the primary focus. The other side was secondary. For a concave lens, when it's parallel to the principal axis, this was the focal point that it emerged from. Right? So this is the primary focus, the other side is the secondary. So it's always the primary is always defined in relation to our first rule. So when I shine a ray of light parallel to the principal axis, which focal point does it go to, or which focal point does it come from? That is our primary focal point. The other one on the other side will be secondary. Yeah.
What's the purpose of the secondary focal point?
It's just for like other rules. Like if we were to have the third rule here, you would use the secondary focal point. Well, we don't have a rule, so we're not going to use it. Needlessly, no confusion necessary. Are we good? We're going to go to our converging lenses. Note that all these are still labeled C. You can change that to an O. Technically, it's the optical center. You can call that an O or a C. It doesn't really matter. Just make it to an O so you don't get confused with the C from a mirror. The C in a mirror, remember, was the equivalent of 2F. This was equal to the center of curvature of the mirror. The optical center is the equivalent of a vertex in a mirror. So, again, optical center, you can write it as an O or a C, as long as you don't get confused with the other C, which is not the same as that point, you're fine. Yeah? Okay, so this is an approximation of a concave convex lens, correct? Everybody good with that? See the convex lens? Convex lens are what kind of lenses? Converging, very good. And just like we had 5 situations for the concave mirror, we're going to have 5 situations for a convex lens. So this is beyond 2f. So part 1, beyond 2f prime, technically. Right, so it's beyond 2f prime. Again, let's draw our rules. Again, we're only going to take this one point. We know that this is going to still lie on the principal axis. It's the same idea as the mirrors. Right, so we're going to draw a line or a ray parallel to principal axis, like so. Passing through focal point, like so. And here you can use the third rule if you like. I think just to stay consistent, we only use the parallel ray and the optical center ray because that's the same thing we're doing for our diverging lens. If you want to use the other rule, by all means you can. I'm not going to. So we'll draw one that's going to the optical center, does not bend and emerges just like that. I will point out, okay, this is important here. There's a couple of key distinctions that you should not get confused with, which are old ray diagrams and our new ray diagrams. Right? This is ray diagram for lenses. Light passes through a lens. There are no dotted lines on this side of the lens. Right? Before we had a mirror where light would reflect and then we had to dotted line it back on the other side. Light passes through a lens. Lens is like transparent medium. So light does pass through. Dotted lines exist on this side. So this is where you'd be drawing dotted lines. Because light, this is imaginary light here now. I mean, if you had to extend these rays back. We'll get to where we're drawing dotted line later. These are not dotted lines, solid lines. Right? You draw real lines because that's actual light that's passing through the lens and coming out on the other side. Is that okay? And then we can draw our arrow. I don't want to be all fancy about this. But there, that's our arrow. We are also going to do salt for these guys. Right, so our size is diminished or smaller. Attitude is inverted. Location is between F and 2F, closer to lens. The location of the image is closer than the object. That's what I mean there. And our type is real. Again, because I'm using solid ray lines, this is a real image that's formed. Remember in our mirrors, if I had it on the other side of the mirror, it was a virtual image. Now if it's on this side of the mirror, it's a real image. Because that's where actual light rays are meeting. Because it's a lens. Is everybody okay with the difference? How it went from mirror to lens. This side is now real images. This relation still exists between the A and the T. Alright? Inverted images are always real. Virtual images are always upright. Yeah. Yeah. Okay, and so we're going to, again, go through these with increasing rapidity. So that was my first rule right there. Yeah, like I said, I'm not the greatest artist. That was the best arrow I could do. Alright, we use our two rules. Very easy. And you'll notice there's a lot of similarities between the mirror ray diagrams and the lens ray diagrams, right? They're formed on different sides, but for a concave mirror, we're essentially going through the same ideas that we had from before. So this is going to be same size, inverted, at 2f, same distance from lens, and real image. Okay with this? Yeah, you could, I mean, I'm sure you could do the salt. You know? We have a couple more to do. 4 more to be exact. So we're gonna, I mean, this was part 2, right? At 2f prime. That was our second part over there. At 2f prime, so part B. Part C, this is between 2f prime and f prime. Well, that's part, there we go. Again, we're going to quickly apply our, 2f prime. Yes.
That's a fine.
Secondaries are primes. There we go. You have to draw long lines for this one.
I was sure mine ended up like off the page almost.
Just put it at the end, the corner of the page, as close as you can get. I'll accept that. Fine. So size is magnified, inverted, attitude, beyond 2f, farther away from lens, real. Again, inverted images, always real. Yes, Shelley, do you have a question? What? Okay. Based on your knowledge of mirrors, can anybody guess what the answer for the part D is at f prime? What kind of image will exist? Does anybody know? Yeah? There won't be an image. Very good. Very similar to our concave mirror. Convex lens, there will be no image. Are you okay? Sorry if I'm going a bit fast. I want to finish this by the time class is done. The video will always be posted on YouTube, so if you do need to catch up, you can go do that as well. Right, these are parallel rays, no image, so no salt. Oops, there we go. Everybody's okay? More or less? Last one for our convex lens. This is the last option, is in front of f prime. Right? This is over there. Now this is again our tricky case, the last one that's kind of weird, because if we do draw these two lines, they appear to be diverging on this side, right? So they'll never meet on this side. So when we don't have rays that are meeting on one side, we have to extend them backwards with dotted lines. Dot, dot, dot. Whoops. There. My arrow. Size is magnified. Attitude is upright. Location is between 2f prime and f prime, farther away from lens. Virtual image. Again, in this case, virtual images are formed on the same side of the object. So you'll notice the difference between mirrors and lenses, right? So when we had in our previous, when we were doing mirrors, if the image was on the same side as the object, we said that was a real image. Those were always inverted because reflection was occurring. Now, because refraction is occurring, because the light is actually passing through the lens, any image that's formed on the same side of the lens is a virtual image. And this is odd, right? Think about like if you have like a big lens over here and the image is formed on your side, right? Isn't that weird? If you think about it, that's a virtual image because it's weird. Real images are formed where they're supposed to form, on the other side of the lens. It's the same table that you were drawing in the for the mirrors, the textbook. There's a table, page 559. You can just copy the table, or we've already written all the answers. You just have to arrange it in table format. I mean, you're just doing salt for all the cases. So whatever we've written before is salt. You just have to fill in this table. It's not like you could do it in like 5 minutes if you're. Hopefully, you're looking at the salt and kind of like remembering what it is. But if you just want to copy it down, it'll take you like less than 5 minutes.
First thing you mark as homework, there's no F.
What?
There's no F. It goes A to F and then he did no F.
I'm confused.
There was no image.
Even practical application.
Oh, okay, there's no F. Oh, it's, okay. Sure. Scratch out that. Never mind. And the applications are also in the textbook. You'll have to do a bit of reading for that one. And we're going to talk about those briefly at the beginning of next class. So we'll go over that part of the homework. 559. It's written on your, it should be on your thing, no? Yeah, okay. Yeah. Okay, what kind of lenses are diverging lenses? Concave lenses. And these are just like convex mirrors. They only give one type of image. So there's no need to draw a bunch of ray diagrams. We're just going to draw one just to get the salt working. So we're going to use our first rule, parallel to principal axis, coming out as if through the focal point. primary focus, right? So we're gonna draw one like that. And then this is the optical center. The center just does that. Again, our two light rays are never going to meet on this side, right? So we have to extend them backwards. This one we've already extended backwards, right? This one, it doesn't extend in any special way. It just goes back. But this one we can extend backwards. And we'll see that they meet over here. Like so. I mean, we can write the salt here, or we can fill it in the table. Both are going to be the same. There's only one size. So we have a diminished or smaller image. Our attitude is upright. What is our location? Sorry? In front of F. In this case, but it'll be closer to the mirror. You're right, closer to the lens, my bad. I said mirror too many times in the last week. And our type of image is what? Very good. Upright, virtual image. And you can fill that in. Don't put the location in front of F for this one, because I'm actually not sure whether it always forms in front of F. You'll have to check the textbook for that. But it will always be closer to the lens. It will always be diminished. It will always be upright. It will always be virtual. Wherever your object starts off. Right there. Alright? Everybody good? That's all we're going to do for today. I'm sorry if we rushed through that. But the video has been